The Abantia Group consists of 9 companies specialized in applied engineering, providing capacity, knowledge, and effectiveness in the most important fields of industrial engineering and new technologies. Abantia is an international group backed by a trajectory with 70 years of experience, providing comprehensive solutions in design, engineering, and construction. Our experience and effectiveness is based on our team, with over 2,100 employees, including over 360 engineers and architects. In Abantia, we have extensive experience in project development and installation of data centers, and specifically in Gulf Cooperation Council countries. Qatar Foundation, Doha, Qatar. MISA, M-Vault 2. MISA, M-Vault 3. 2454, Abu Dhabi, United Arab Emirates. CAR, room at Studio B. Abantia will count on Quorum Business Group as an experienced local partner for the project. Quorum Business Group is an international, diversified business services group, which, led by Sheikh Ahmed bin Sultan Saif Al Hosni, Chairman, and Sheikh Abdul Aziz Al Hosni, Vice Chairman and President, and Board of Directors, with operations across the Middle East, Europe, and the Indian subcontinent, rooted in Oman, with more than 40 years' experience. Supply and implementation services for the upgrade of the National Data Center. The main purpose of the project is to upgrade the National Data Center to reach Tier 3 as per Uptime Institute and TIA 942-2 international standards, providing new cloud and networking areas in the server's room. External works. Project works will start with 2 new trenches that will be excavated, one running from Generator's site to the new Electrical Room 2, and the other running from Transformer's compound to the new Electrical Room 2. PVC ducts will be laid down on trenches to allow new power wires for both new utility and Generator's power source branch number 2. Electrical rooms. Current battery room number 1 has to be revamped and prepared to allocate new and existing switchboards, UPS, etc., and it will be labeled as electrical room number 2. These are the steps to accomplish the requirements of the project. First of all, existing batteries in battery room 1 will be carried out from battery room 1 to battery room 2 to fulfill 10 minutes capacity requirements, and the rest will be stored in a facility of ITA. And then there will be available space in battery room 1 for new equipment. From now on, this room will be labeled as electrical room number 2. Secondly, new cable trays will be laid under existing raised floor for new cable paths between electrical rooms 1, 2, and existing UPS room. Next, project documents propose UPS's number 4, 5, and 6 to be moved to new electrical room 2. We have considered this UPS are not necessary to be moved and could remain at their current position. And then all the available space in electrical room number 2 can be used only to allocate electrical main and secondary switchboards. The next step is to move PDC-DB2, MSS-2, and UPS main BD-Bank 2 to electrical room number 2. At the same time, 2 new cracks will be installed in the UPS room and stage room. Final steps will be installing new AMF-2 main switchboard and switchboards feeding cracks ACDB2, 1, 2, and 3. Server's room. In order to reduce migration time, schedule, and harms to existing equipment, The migration process will be as follows. First of all, plastic strip curtains will be installed surrounding the existing racks containing the airflow in the cold aisles. Air overpressure and cold aisles will avoid dust and particles entering the racks, thus protecting electronic devices, switches, etc. Secondly, new trays, power cables, and power distribution cabinets will be installed for each new row of servers. Copper and fiber data cables will be available for the new links described in the project. New racks layout will follow the cold-hot aisle principle. After that, all necessary infrastructures will be prepared for network and servers equipment. Then, all existing network equipment can be moved from the existing rows to new rows location, including all performance and safety tests. During each movement, a backwards procedure shall be established in the case of not achieving the relocation on time. Now, old rows of racks will be dismantled, making available space, and thus existing cracks can be moved to their new position. Only one crack will be moved at the same time to mitigate affection to the functioning networking equipment. New rows of racks will be installed in the network and cloud zones once all necessary infrastructures are available, including VESTA fire detection, FM200 fire extinguishing, access control system, and surveillance. All this system software has to communicate and work together with the previously existing at the National Data Center. After this, all new walls can be erected to separate network and cloud rooms from the rest of the server's room. Finally, switches, fiber channel over Ethernet, perimeter and anti-intrusive firewalls, and load balancers for G-Cloud layer have to be installed in the rack's networking equipment for this room's dedicated equipment radius. According to the documents regarding this project, our experience in this kind of work, the experience of our local partner QBG Contracting in Oman, and the methodology presented, we can assume and consider a 6-month period to complete these works.